While the entire automotive world is engaged in a frantic, high-stakes race toward electrification, fixated on lithium mines and gigafactories, a quiet but seismic shift is happening in the background. It is a shift that most mainstream media outlets are ignoring, yet it holds the potential to completely rewrite the future of global transportation. We are talking about a move by an industry titan, Cummins, that challenges the current narrative that electric is the only way forward. The CEO of Cummins has dropped a bombshell, leaking details about an engine technology that doesn't just promise to compete with electric vehicles, but potentially render them obsolete in the sector that matters most, heavy industry. The question hanging over the industry is no longer just about horsepower or torque. It is about viability. Can a hydrogen engine truly challenge the dominance of the electric motor? Or is this the desperate gasp of a legacy diesel company refusing to let go of the past? To understand the magnitude of this development, we have to look beyond the headlines. We need to imagine an engine that sounds, feels, and performs exactly like the diesel workhorses we have relied on for a century, yet emits nothing but water vapor. An engine that eliminates the crippling charging anxiety of the logistics world and powers the heaviest machines on Earth without pausing for hours to plug in. This is not science fiction. Cummins claims this is happening now. But can they actually pull it off when giants like Tesla and BYD are betting billions against them? To understand the future, we must first understand the weight of the past. For decades, the name Cummins has been synonymous with one thing: unshakable reliability. In the rough-and-tumble world of heavy trucking, mining, and industrial power, Cummins wasn't just a brand, it was the standard. Their identity was forged in iron and oil. Whether it was a road train crossing the Australian outback or a generator keeping a hospital running during a blackout, the engineering philosophy was simple: build it strong, make it run forever, and ensure that once it's installed, the owner never has to worry about it again. Cummins was never a company interested in the flash and glamour of the consumer auto show circuit. They didn't do hype, they did torque. However, the tectonic plates of the auto industry began to shift. The global conversation turned aggressively against fossil fuels. Diesel, once the hero of industrial progress, was suddenly villainized. Carbon footprints, particulate matter, and emission targets became the new metrics of success. The writing seemed to be on the wall for companies like Cummins. The prevailing logic was that the internal combustion engine, the very heart of Cummins' existence, was dead, destined for the museum alongside the steam engine. The world was pivoting to batteries, and the assumption was that heavy industry would simply have to follow suit, regardless of the difficulties. This is where the story takes a fascinating turn. Instead of bowing to the pressure to become just another battery manufacturer, Cummins made a contrarian decision that shocked the market. They analyzed the landscape and realized a fundamental truth that the EV enthusiasts were glossing over. The problem was never the engine itself. The problem was the fuel burning inside it. Cummins realized that if they could keep the mechanical reliability and thermal efficiency of the internal combustion engine, but swap the dirty fuel for a clean one, they wouldn't just survive, they would change the game entirely. This realization birthed the journey from diesel to hydrogen. It wasn't a knee-jerk reaction to stock market pressure. It was the result of years of deep, practical research into the physics of energy. Cummins understood that while electric vehicles are fantastic for passenger cars and light delivery vans, they hit a massive wall when it comes to heavy haulage. In the world of long-haul trucking and industrial mining, time is the most expensive commodity. A truck that is sitting at a charger for 4 hours is a truck that is losing money. In this brutal economic reality, hydrogen emerged not as a fad, but as the only logical path to combine the brute force of diesel with the cleanliness of the future. But this pivot carries immense risk. Cummins is effectively betting the farm on a technology that the rest of the world has been skeptical about. They are daring to move away from their core identity of diesel, risking their dominance to chase a future that isn't fully built yet. This isn't the reckless gamble of a Silicon Valley startup with nothing to lose. This is a calculated risk by a century-old industrial giant with everything to lose. They are operating on the belief that the future will not be a monopoly of one technology. They see a world where EVs, hydrogen, and other alternative fuels coexist, each serving the specific needs of different sectors. So what exactly is this hydrogen engine that has caused such a stir? When we hear hydrogen vehicle, our minds usually jump to fuel cells, complex chemical laboratories on wheels that convert gas into electricity to drive a motor. That is not what we are talking about here. Cummins is championing the Hydrogen Internal Combustion Engine, H2IC. The beauty of this technology lies in its simplicity. It is, for all intents and purposes, a standard engine. It has pistons, it has a crankshaft, and it has valves. The only major difference is that instead of injecting a mist of diesel and air, it injects hydrogen gas. When hydrogen burns, it releases massive amounts of energy, but unlike carbon-based fuels, it doesn't release carbon dioxide. The byproduct is essentially heat and water. For a mechanic or a fleet operator, this familiarity is a godsend. You don't need to retrain your entire workforce to become high-voltage electricians. You don't need to throw away 50 years of mechanical knowledge. The driver gets in, turns the key, hears the engine roar, and drives. The sensory experience remains visceral and familiar. This psychological factor, the bridge between the old and the new, is a massive strategic advantage that Cummins is leveraging. Now, we must address the elephant in the room. Why choose this over an EV? The debate largely comes down to energy density and uptime. An electric truck requires a battery. To move a 40-ton load over a mountain range, that battery needs to be colossal. We are talking about thousands of pounds of lithium-ion cells. This creates a parasitic effect where the truck is using a significant portion of its energy just to carry its own fuel source. This added weight reduces the amount of cargo the truck can legally carry, which directly eats into the profit margins of the logistics company. Then there's the issue of refueling. In the current logistics model, a driver pulls into a depot, fills up with diesel in 10 minutes, and is back on the highway. Replicating this with electricity is currently impossible without megawatt-scale chargers that would melt most grid connections. Hydrogen, however, mimics the diesel model perfectly. You connect a nozzle, the pressurized gas fills the tanks in minutes, and the vehicle is ready for another 500 miles. For industries that run 24/7, like open-pit mining or cross-country shipping, this difference isn't just a convenience, it's a necessity. Furthermore, we have to consider the environment in which these machines operate. Batteries are chemically sensitive. In extreme cold, their range plummets. In extreme heat, their cooling systems struggle. An internal combustion engine, however, is a thermal machine. It thrives on heat and is robust enough to handle the cold. By sticking to engine technology, Cummins is ensuring that their machines can operate in the frozen tundras of the north or the scorching deserts of the equator without a drop in performance. But is the hydrogen engine the enemy of the EV? This is the narrative that usually gets pushed, but it's a false dichotomy. The truth is far more nuanced. Cummins isn't trying to kill the electric car. They are trying to save the heavy-duty sector from a solution that doesn't fit. Electric powertrains are undoubtedly superior for urban environments, stop-start traffic, and short delivery routes. But for the heavy lifting that keeps the global economy moving, hydrogen fills the gap that batteries simply cannot bridge yet. It is not a war between technologies, it is a specialization of tools. However, no discussion about hydrogen is complete without addressing the critical bottleneck: infrastructure. The skeptics will immediately point out, where are the stations? And they are right. Today, hydrogen refueling stations are rare, but viewing this as a permanent blockage is a failure of imagination. We faced the exact same chicken and egg problem when gasoline cars first appeared, replacing horses. We saw it when CNG was introduced. We are seeing it now with EV chargers. Infrastructure always follows demand, never the other way around. The brilliant insight in the heavy-duty sector is that you don't need a hydrogen station on every street corner. You don't need the ubiquity of gas stations because commercial trucks don't drive randomly. They operate on fixed routes and return to central hubs. If you build a hydrogen station at a major port, a logistics depot, or a mining site, you have instantly solved the infrastructure problem for hundreds of vehicles at once. This hub-and-spoke model turns the infrastructure challenge into a massive business opportunity. Investors are beginning to realize that owning the refueling points for industrial fleets is a guaranteed revenue stream for decades. This is where the global implications become staggering. The shift to hydrogen isn't just about engines, it's about energy independence. Nations that are currently